Welcome back to my YouTube channel. As stated previously, this video is going to be dedicated to derivatives. Now there's four main rules. As you can see here, we have the power rule, product rule, quotient rule, chain rule. Now the first one we're going to be talking about today is the power rule. In the coming videos, we'll talk about the next three rules. Now the power rule will pop up a lot, so we're going to do plenty of examples, and so let's go ahead and get started. Remember, this is assuming that you've already taken a Calculus 1 class, but I'll just write it out here. What is the power rule? The power rule is as follows: d dx. So this is saying take the derivative of whatever I'm about to write. So take the derivative of, let's say we have a variable raised to a constant, and taking the derivative of that says, hey, bring that variable to the front, multiply by that, bring that constant to the front, multiply by that variable, and then take one away from the constant. Okay, so now let's find the derivative for our first question. So let's find dy dx of y equals x to the sixth plus 2x minus 1 over x. So what does this dy dx mean again? All that says is, hey, take the derivative of y with respect to the x variables. So this says what you need to take the derivative of, and as you can see, y is right there, so we need to take the derivative of y with respect to what? Respect to the x variable. Okay? If this is written a little bit different, say dt d theta, and say we're given a function t is equal to sine theta squared, well, all that means is, hey, take the derivative of t, which is sine theta squared, with respect to the theta variable. Okay, so this always tells you what to take the derivative of with respect to. This is going to be important whenever we talk about implicit differentiation. But for now, we're just going to be dealing with a single variable. So how do we do the first one? Well, the way I like to do it is I like to put dx, take the derivative, and I like to simplify whatever is in here. So x to the sixth, leave that alone, plus 2x, leave that alone. Now, whenever I see something like this, I usually like to write it so that we have something to a power. So that's minus, and if we bring that x to the top, that's x to the minus 1. It's just more convenient. You can still do it this way. But that's going to require a quotient rule, which we haven't talked about yet. Okay? So let's go ahead and compute this derivative. Well, we know for the first one, x to the sixth, we're going to bring that 6 to the front, multiply by x, take 1 away from the variable, so 6 minus 1, plus, now if we look over here, we see that x is raised to the first power, so 1 times 2 is 2x to the 1 minus 1, minus, well, if we look over here, if we bring that minus 1 to the front, there's a minus sign there. So a negative times a negative makes a positive x. Now we have negative 1 minus 1. Okay, so now let's simplify that. And we call our derivative, we can call it y prime if we want. So we'll call it y prime is equal to our derivative. There's a couple ways to write what the derivative is. We can also write this as dy dx. Same thing, different notation. So for the first one, we're going to get 6. Now, 6x to 6 minus 1 is 5. plus 2x, but 1 minus 1 is 0, and anything to the 0 is just 1. Anything to the 0 is just 1, so this will just be 2. 2 times 1 is 2, plus x to the negative 1 minus 1 is equal to negative 2. So either one of these is okay. You can leave it like that, or you can write it as dy dx is equal to 6x to the 5th plus 2 plus 1 over x squared. You can just rewrite this x to the minus 2 as 1 over x squared. And that is a derivative of y with respect to x, where y was x to the 6th plus 2x minus 1 over x, and its derivative is 6x to the 5th plus 2 plus 1 over x squared. Let's move to example 2. So I'm just going to write it like this. D dx says, hey, let's find the derivative of this function. Now it's going to be 1/6 x to the 4th plus 2 over x cubed. So, like I said, I like to simplify first. So 1/6 x to the 4th, that's good. Now plus, we can write this 2 over x cubed as 2x to the minus 3. Still the same thing. Okay, so let's go ahead and compute that derivative. We'll just call it y prime is equal to, well, we got to bring that 4 down, so it's going to be a 6th times 4. X to the 4 minus 1 is 3. That's a 3. That's a 3. Now, we're going to bring that minus 3 to the front. Multiply that by 2. X to the minus 3 minus 1 is minus 4. So y prime is equal to 4 over 6 x cubed minus 3 times 2 is 6, x to the minus 4. So our final answer should be 4 over 6, which reduces to 2/3, x cubed minus 6, x to the minus 4th, we can write that as 1 over x to the 4th. And there's our answer. Example 3. Say we're given y is equal to 1 over e theta to the 7th plus pi natural log of 2 squared over the square root of x minus x to the 1/2 power cubed plus 7. Okay? So what if we want to find the derivative of that? So let's find the derivative with respect to theta of this. Oh, I'm sorry. That should be x. How do we go about doing that? Well, for the first one, well, let's go ahead and simplify actually. So we get 1 over e x to the minus 7th. Remember, 1 over e is just a constant. The derivative of a constant is just 0. Sorry, the derivative of a constant is just 0. Plus, now we just take out our constant, and by way of log rules, this can be rewritten as 2 natural log of 2. So we'll go ahead and write that like that, 2 natural log of 2. So we're going to get 2 pi ln of 2 times, now that's x to the 1/2 power. Same thing. So that's 1 over x to the 1/2 power. So if we write that on top, we're going to get x to the minus 1/2 power. Okay. Minus Well, that's just x, and we can multiply this 3 by that 1 divided by 2 plus 7. Great, so now it's all simplified. Where this is a constant, this is a constant, and that's a constant. So y prime is equal to 1 over e times the derivative of that, bring that down, bring that negative 7 down, x to the negative 7 minus 1 is minus 8, plus, now all this is just a constant, and we can multiply that by the derivative of x to the negative 1/2, or we could bring negative 1/2 down, x, negative 1/2 plus 1 is negative 1/2 plus 2 over 2. Now we have a common denominator, now we can add them. So negative 1 plus 2 is 1. Keep that denominator and we get a half. Okay. Minus, now we could bring that 3/2 down. It's going to be x to the 3/2 minus 1, which would be minus 2 over 2, which will be, again, a half. And then plus 7, well, the derivative of a constant is just going to be 0. Great. So there's a derivative. Now all we have to do is simplify. So for the first one, we're going to get negative 7 over e. Now x to the minus 8, well, we can make that positive. We'll bring it down. Bring it downstairs. Plus 2 pi ln of 2 times this. Well, there's a negative sign in front of this minus 1/2. Negative sign in front of that 1/2, which makes this all negative. So it'll be minus 2 pi ln of 2 x to the 1/2, which is just root x, over 2. And we move on to this part, which we're going to get minus 3 x to the 1/2 is just root x divided by 2. And that's our answer. And we can put these two together if we want, but we'll just leave it like this. That was example 3. Now let's move on to example 4. Say we're given y is equal to 2x squared minus x multiplied by x squared minus pi x to the 4th. Say we want to take the derivative of that. How do we do so? Well, we can do some simplifying, because we can see right here that we have a product, and we can just multiply that together. So for the first one, we're just going to FOIL all that out. So we're going to get 2x to the 4th minus x cubed minus pi x to the 4th. Okay. So now what we can do is just take the derivative. So dx, y prime is equal to the derivative of 2x to the 4th, which will be 4 times 2 is 8, x to the 4 minus 1 is 3, minus 3, x to the 3 minus 1 is 2, minus pi is a constant, so we're going to bring that 4 down, x to the 3rd. And we're all simplified there. Now let's move on to example 5. Say we're given a function, say that we're asked to find the derivative with respect to x of a function ln of 1 times x to the 5th minus e squared ln of e x cubed. Now this seems a little complicated because we've seen natural logs, but let me remind you that that's not ln of x, that's not ln of x, that is ln of 1. ln of 1 is a number, that number is 0. This is something else, the derivative, that is. So ln of 1 is 0, So we can rewrite this as d dx. Well, ln of 1 is 0. 0 times x to the 5th, well, that's just going to be 0, minus e squared. Now ln of e is equal to 1. So that just goes to 1, and we get x cubed. So all we're taking the derivative of is simply negative e squared x cubed. Now let's not forget that e squared is a constant as well. So y prime is equal to negative e squared. And we're going to multiply that by the constant, by the derivative of x cubed, which is going to be 3x squared. So y prime equals negative 3e squared x squared. Great. So now let's go into example 6. So this one's going to be a little bit longer. So d dx, take the derivative of y with respect to x of 1 over x to the 4/3 times ln of sine of pi over 3 minus ln of cosine of pi halves. Okay, so first of all, we see again that this is not sine of x, so we're not going to take the derivative of that because we have sine of pi over 3, which is a constant. The derivative of a constant is simply 0. So in order to do this one, let's go ahead and simplify. So d dx of 1 over x to the 4/3. Now recall that ln of a minus ln of b can be rewritten as a single logarithm as ln of a over b. So that's what we're going to do here. We're going to rewrite this as ln of a over over cosine pi halves. Great. So now all of this is just a constant. You can compute that if you want. Which, if you wanted to, sine of pi over 3 is simply root 3 over 2 over cosine of pi halves. Well, the cosine of pi halves is actually going to be 0, which is not possible. Let me make that. It should have been pi thirds. Sorry for that mistake. It should have been pi thirds. That's better. So the cosine of pi thirds is going to be 1/2. And if we multiply that out, 1 over 2, do the reciprocal of that, it's 2 over 1. 2's cancel, and we get root 3. So we're going to get ln of root 3, which is ln of 3 to the 1/2, which by powers of logs, we can make this 1/2 ln of 3. So we can rewrite this as d dx of 1 over x to the 4/3 multiplied by ln, a half ln of 3. Well, half ln of 3 is just a constant, so we can pull that on the outside. So half ln of 3 d dx. Now we can rewrite 1 over x to the 4/3 as x to the minus 4/3. So all we have to do is take the derivative of this and multiply it by the constant. What's the derivative of this? Well, that's just negative 4/3 x to the negative 4/3 minus 1. So negative 4/3 minus 1 equals negative 1/3, which we can rewrite as negative 4/3 x to the 1/3 power. So we're going to get multiplied by negative 4 over 3 x to the 1/3. So y prime is going to be equal to, well, negative 4 times 1 is negative 4 still, over, what, negative 4 ln of 3, over 2 times 3 is 6, third root of x. What I did there is I rewrote x to the 1/3 as a third root of x. Same thing. So there's our answer. Example 7. Say we're asked to find the derivative Sorry about that. Say we're asked to find the derivative of e to the 9th over 4 squared of ln of the absolute value of sine of pi halves cubed multiplied by x. That looks a little bit complicated, but let's realize that all of this is just a constant. So that's just going to be on the outside. E to the 9th over 4 squared ln of sine of pi halves cubed times the derivative of a lonely x. Okay, so what's the derivative of x? The derivative of x is just 1. So y prime is simply equal to e to the 9th ln absolute value of sine of pi halves cubed we can't write it like that, all over 4 squared. Okay, so let's move on to example 8. Say we're asked to find the derivative of 2x minus x. There's nothing to simplify here, or we actually can simplify that. So 2x minus x, remember this is just a 1, so 2 minus 1 is x. So y prime equals 1. Example 9. Say we're given y is equal, or say that we're asked to find the derivative of x times x to the 4/3 times x to the minus 1/2 times x over x to the 9/2. First of all, let's go ahead and simplify this. So dx. Well, for the first one, that's raised to the first power. So 1 plus 4/3 is 7/3. Let's make this a little larger. So we get x to the 1 plus 4/3 is 7/3. So we're done with those. And we have this x to the minus 1/2, which is going to go to the bottom. And we have this x to the first power. So we're going to multiply that by x over, move this x to the 1/2 to the bottom. So we have x to the 9/2 times x to the 1/2. So what are we going to get? Well, for the top one, remember this is to the first power. So 7/3 plus 1 is what? No, I'm sorry. Oh, yes. That is a multiply sign, not a minus sign. So what are we going to get? 7/3 plus 1 is x to the 10/3 over now 9/2 plus 1/2 is x to the 10/2. 9 plus 1 is 10 divided by a common denominator of 2. So now we have x to the 10/3 over x to the 10 divided by 2 is 5. Great. So now we know that we have x to the 10 thirds we have an x to the 5th on the bottom, and we have an x to the 10 thirds on top. So how do we find that answer? Well, what we can do is just take x to the 10 thirds over x to the 5th and make the x to the 10 thirds minus 5 is equal to x. Now if we subtract that, we're going to get 15 on top. So 10 minus 15 is negative 5 over 3, which is the derivative of that. So x to the minus 5 thirds is equal to what? Well, it's going to be minus 5 thirds. X to the negative 5 thirds minus 1. So we're going to get negative 8 thirds. So y prime is equal to negative 5 thirds over x to the positive 8 thirds. Alright, that was number 9. Now let's do number 10. Which is find the derivative of x over 1 over x cubed times x to the minus 1. Okay, so how do we go about doing this? Well, let's simplify. So we're going to get x over 1 times the reciprocal of that, which is x cubed over 1 multiplied by x to the minus 1 can be rewritten as 1 over x. So d dx of x to the first power, x to the third, which is x plus 1 plus 3, which is x to the 4th, over, now we just multiply this x to the bottom. Now we got d dx. That's to the first power. So 4 minus 1 is x to the third power. So y prime equals 3x squared. Alright, well, there's 10 examples. Hopefully you learned something. And like the video, comment, subscribe, and I'll see you in the next video.